All right, now we're going to take everything we just talked about and put it into larger equations, more complex equations. But before we go any further, equations. We talked about functions. What is a function? How do we know if something's a function? Yeah, we talked about it way, way, way long ago, yesterday. It's a one-to-one correspondence, meaning that for each x value, there's one and only one y value. The graph, if you draw a vertical line, if it touches it more than once, it's not a function. So functions and equations are synonymous. What's the difference between expressions versus equations? What's the difference? You've heard them both before, and you can be asked these on any question in a math problem. Equations hence equal equation. Expressions do not have an equal sign. So that's what they look like first. But what you do with them is completely different. In equations, since it has an equal sign, you solve. In other words, you're not done until your variable equals a number. Those are equations. You have to solve for a value, or it can be an equation. Y equals mx plus b. That makes it an equation. Expressions, you simplify, combine like terms. Those are the difference. So whenever you see, if it says in there, find or simplify this equation, well, they're synonymous. If it says simplify, you know it's an expression. If it says solve, you know it's an equation. There has to be an equal sign there. All right, so that's important to know. We have two principles that we deal with. The first one is the addition principle. What it says is this: if we have two terms, if A equals B, then if I add the same value to both sides, they're still equal. Why is that important? Does it have to be addition? It can be subtraction also. When will we use something like this? Well, let's see. Basically, think of the golden rule. Whatever you do to one side, you got to do to the other side. So if I want to get rid of the 5, if I subtract 5 from that equation, I got to subtract 5 from this equation. And since I'm subtracting the same amount, I keep equality. That's what it's used for. The second one is the multiplication principle. What this one says, again, if A equals B, then if I multiply the same term to both sides, I keep equality. Whatever I do to one side, I got to do the same thing to the other side. Again, it doesn't simply, what it says is whatever I do to one side, I can do the same thing. So what can I multiply both sides to get X by itself? No. Because, okay, now, if I gave you this, what would you do to both sides? To get X by itself, what do you do? Okay, you said divide by 3, but a second ago, what did you say? So when you divide, what you're really doing is multiplying by the coefficient. Because if you multiply these together, you get 3 over 3, or 3x over 3. So that's mathematically what's happening. So the 3's cancel, which is something here, and the 3's cancel here. If I had that, would you divide by 4 over 5? I said, need more paper here. The answer is yes. Because this can be rewritten as 4 over 5 x. Like we just did in this one. Whatever my coefficient is, I can divide by it. Whatever my coefficient of x is, I can divide both sides by it. So what's my coefficient of x? The coefficient means what's in front. 4 is not in front of it. 5 is not. It's 4 over 5. So I do that to both sides. Okay, now what happens here? Whenever you have a fraction over a fraction, take the top fraction and leave it alone. Multiply it to the flip of the bottom. Think about that. So I take the top fraction, leave it alone. Multiply by the flip of the bottom. There's still that x there. Is this a fraction? Yeah, every number is a fraction. Every number is a fraction. 2 is a fraction because it's 2 over 1. So I take the top fraction, leave it alone, multiply by the flip of the bottom. What happens on the left side? What do you get? Again, do not multiply before you divide. Whenever you multiply fractions, always reduce first. The 4's cancel, the 5's cancel, so we're just left with x. You'll make less mistakes that way. How about here? The 2 cancels with the 4, so that becomes a 1. So we just have 5/2, and that's your final answer. Solve this equation. Let's see who remembers what I just talked about. So we have fractions and equal signs. So the first thing we do is find the LCD. What's the LCD in this example? 20. 5 times 4 is 20. So I multiply 20 to each term. Third step, reduce. What cancels? 4 goes into 20 how many times? 5. 5 goes into 20 4 times. Now we multiply. 5 times 3 is 15x. 20 times 1 is 20. 4 times 7 is 28. Solve for x. Get rid of the non-x's first. We want all the x's to one side, all non-x's to the other. Can 48/15 be simplified? Do they have anything in common? Yes. Earlier this week, I told you all shortcuts for finding out if things are divisible. How do we know if it's divisible by 3? Is 15 divisible by 3? If you add 1 plus 5, it equals what? Is 6 divisible by 3? Yes. How about 4 plus 8? Is that divisible by 3? Yes. So both of these are divisible by 3. 3 goes into 4 one time with 1 left over. 3 goes into 18 6 times. 3 goes into 15 5 times. You can enter your answer that way. It's an improper fraction because the top is bigger than the bottom. Or we can rewrite it as a mixed number. How many times does 5 go into 16? 5 times 3 is 15, so it's 3 times. With how many left over? 1. over 5. That's how you find mixed numbers. Find out how the maximum number times the bottom number goes on the top, and whatever's left goes on top. Yes. Actually, when deal with computers and entering stuff, this is easier for them to program, so this is what they prefer. But in the world of mathematics, you never leave it in proper fraction. Always put it in mixed numbers. Okay. Example 2. So what do you think the instructions for this problem would be? Would we solve or simplify? Solve. Why? Because there's an equal sign. If there's an equal sign and there's variables, then you have to see what they equal. So you have to solve it. So how do you solve this one? What do you got to do first? Get rid of the parentheses. Well, first off, order of operations. Can you do anything inside the parentheses? No, we can't do 5 minus 3x, not like terms. So we can't do anything inside there. Can we do anything outside? Yes, we can multiply. Now we follow order of operations. 2 times 5 is 10. Positive times negative is negative. 2 times 3 is 6x equals 8. Negative times positive is negative. 3 times x is 3x. Negative times positive is negative. 3 times 2 is 6. Whenever you get rid of parentheses, the first thing you want to do is combine like terms. Nothing on this side. Here we have 8 minus 6. 8 minus 6 is 2. Minus 3x. We're solving for x. So what do we do now? Well, you have to get x's on one side. So which x do we move? So here. If you have x's on both sides of the equal sign, move the smaller x to the larger x. So, which ones are smaller x? No. By smaller, think of a number line. Is 1 smaller than 2? Why is it smaller than 2? Because it's further to the left on the number line. On the negative side, so -6 is smaller than -3. So what we have to do is we have to move this number to that side. How? By adding 6x to both sides. When you do that, your x is always going to have a positive coefficient. 10 equals 2. Positive, negative, 6 is bigger. 6 minus 3 is 3x. See, now our coefficient is positive. We don't have to worry about sign changes. If you move the 3 to the other side, you'd still have a negative 3 on this side. Then you have to worry about sign changes. So we have all the x's to one side. Get rid of the non-x's. Move them to the other side. And then get the x by itself. So x is equal to 8 over 3. Or 3 goes into 8 2 times. 2 times 3 is 6, so there's 2 left over. This denominator will always be in the denominator. Negative 24x plus 7 equals 17 minus 24x. My first step is what? I have to get all the x's to one side. Okay, first off, are there any parentheses or anywhere? Because you have to first get rid of the parentheses. Now, since we have x's on both sides, how do we get the x's to one side? What do? We have to add 24x to both sides. Are those equal? So what does that mean? If we look at these two lines, remember, if we look at this side here, since the x's on both sides, we have negative 24x plus 7. That's this side. That's the left side. On the right-hand side, we have negative 24x plus 17. So what kind of lines are they? What do you notice about them? They have the same slope. What else do you notice? Different y-intercepts. If they have the same slope, different y-intercepts, how are they related? They're parallel. If they're parallel, how many solutions they have? None. So whenever you get into this situation, there's no solution because they never intersect. So you can either set both sides, set them equal to y, or solve them equal to y, or work it out. And if all the x's disappear, and the numbers are not equal, it's no solution because they're parallel. Three minus 1/3x equals negative 1/3x plus 3. Okay, we have fractions and equal sign. So let's practice our skills. What's my LCD? So multiply my LCD to each term. Put a 3 in front of each one of my terms. Reduce. So that 3 and that 3 cancel, that 3 and that 3 cancel. So we're left with multiply. So we have 9 minus x equals negative x plus 9. Now we solve. Add x to both sides. Does 9 equal 9? Yes. So it tells us we have an infinite number of solutions because they're the same line. So if you get to a point where all the x's disappear and both sides are equal, then you have an infinite number of solutions. Now let's do applications. Applications are a fancy way of saying word problems. All right, so here they are. Here is the first one you guys have in your packet. Example 5. World languages. There are about 232,000 words in the Japanese language. This is 19% more than the number of words in the Russian language. How many words are in the Russian language? So how do we set this up? Again, you have to learn how to start reading for specific information. So what does the first sentence tell us? Yeah, the Japanese language has 232,000 words. What's the second sentence tell us? So how do I put that in an equation? How do I put that in mathematics? That's just you just converted that to decimals. That's not giving me an equation. Said that this is what is this? This is 19% more than the words in the Russian language. When they say this is, what are they talking about? What is this? Nope. What's that? Nope. Read the first two sentences again. Nope. This refers to the Japanese language, the words in the Japanese language. So this number is actually, I'll use the letters first. The Japanese language is, instead of using the word is, we use equal sign. 19% more than the number of Russian words. How do you put that mathematically? 19% more than the Russian language. We're not graphing an equation. In other words, the more if you look at it that way, what you're saying that if Russia gets more words, then Japan has to get more words. It's not an equation like that. This is saying exactly how many numbers and how many words there are. So the number of words in the Japanese language, that's what this is. It says the Japanese language is 19% more than the Russian language. Why 119?
Because 100% will be the whole Russian language plus the 19% of Japanese. That'll be
Like that. Because you're right. Because you have to start off, are the Russians and Japanese the same? No. So what would make them the same is if I added 19% more words to the Russian language. This is what I'm saying, is when now you guys start learning how to read for specific information and understand what it's telling you. What it's saying is the Japanese language has 19% more than the Russian language. So if they were equal, that'd be great. But we have to add more words in the Japanese language. How many more words? 19% more than what they have already. %19 converts to 0.19. So this is 1 plus 0.19 is 1.19. Do we know what J is? J is the number of words in the Japanese language, which is 232,000 of them. How do we solve for R? So the number of words in the Russian language is determined by that formula. $232,000 divided by 1.19. So there is approximately 194,947.98. Which means it's 194,948,000 words in the Russian language. Because if we had R plus 19% of R, what number is in front of R? I have to go through the distributivity, the associativity, community rules with y'all. So since both of these numbers equations have R, I have 1 plus 0.19. Since they both have an R, I can take out the R. What I'm left with is 1 plus 0.19, which is 1.19. Yes, I have to go through the properties of math with y'all. Because I never did that in the first day. I didn't do the properties, I didn't do the order of operations with y'all. Yes.
Is it?
Oh, is it? I must have written that down wrong. 957. Yeah, thank you. So that's how you compare. But whenever something's increasing, it's increasing from what? It's increasing from what it has now. So it's whatever you have now plus how much you're increasing it by. If it was decreasing, then it would be a minus sign. Let's look at the next one. A convenience store. In 2014, there were 151,282 convenience stores across the US. The total number of stores in Texas and California equaled 26,397. There were 4,003 more stores in Texas than in California. Find the number of stores in both Texas and California. Okay, so what do each sentence tell us? Is the first sentence even necessary? Why not? That's all the states. And we're only interested in what? California and Texas. So the first sentence is just flu information that we don't even need. It has nothing to do with what we're talking about. So the next sentence, the total number of stores in Texas and California is 26,379. So how do we put that in an equation? What it's telling us is the number of stores in Texas plus the number of stores in California have to equal 26,379. Now, the next sentence tells us, so here's the overall statement. Now, how are Texas and California related? There were 4,003 more convenience stores in Texas than in California. So are Texas and California equal? No. How do I make them equal? To where? To California. Yes, I have to add 4,003 to California to equal Texas because Texas has 4,003 more stores. So far, so good. Now, because my equation of here, I have one equation, I have two variables, I cannot have that. You can only have one variable and an equation. That's where this comes in. In place of t, I can put this in its place. So in place of t, I could put California plus 4,003 plus California equals 26,379. Now I have one equation with only one variable. Solve for C. C plus C is 2C. $26,379. Solving for C, so we get rid of the 4,003. Nine minus 3 is 6. 7 minus 0, 3 minus 0, 6 minus 4 is 2, 2. Divide both sides by 2. 2 goes into 2 once. 2 goes into 2 once. 2 goes into 3 once with 1 left over. 2 goes into 17 8 times with 1 left over. And 2 goes into 16 8 times. So those are the number of stores in California. How many stores are in Texas? Well, remember, Texas is California plus 4,003. So we have to take this number and add 4,003. That gives us Texas. 8 plus 3 is 11. Carry the 1. There are 15,191 stores in Texas. How do we check that? Yeah, add them together. 11,188 plus 15,191. And together they should equal 26,379. 8 plus 1 is 9. 8 plus 9 is 17. Carry the 1. 1 plus 1 plus 1 is 3. 1 plus 5 is 6. Check. So you see, each sentence will give you another piece of the puzzle if it's worth anything. If the first one didn't mean anything. So you have to first learn how to decipher what's important, what's not important. Motion problems. Whenever you deal with things that move, we use this formula. Distance equals rate times time. When we say rate, we're talking about speed or the velocity of the object. So let's see what we have here. It tells us Delta Airlines fleet includes 737s, each with a cruising speed of 517 miles an hour, and Saab 340s, each with a cruising speed of 290 miles an hour. Is that important to know? Yeah, because we need to know the rate of the airplanes, how fast they travel. Suppose that a Saab 340 takes off and traveling at its cruising speed. 1 hour later, the 737 takes off and follows the same route at its cruising speed. How long will it take the 737 to overtake the Saab 340? So they both start off from the same airport. They just took off at different times and they're heading the same direction. This is how we set it up. This is the plane. We have the distance, the rate, and the time. So we have the 737 and the Saab Ocean 340. Do we know the distance they traveled? No, but we do. It's asking us, how long will it take the 737 to overtake the Saab 340? So what do we know about the distance? The distances have to be the same. They both took off from the same place at different times. But the moment they both reach the same distance, then the other plane will pass it by. So what's the rate of the 737? 517. What's the rate of the Saab 340? 290. Remember, it's distance equals rate times time. But we do know, did they both take off at the same time? No. Who had more flying time? Who took off first? The 340. How much longer flying time did it have? 1 hour. So it took off 1 hour before the other one. So far, so good. Since we know the distances have to be the same, the distance of the 737 has to equal the distance of the 340. So we put these formulas in there. 517t has to equal 290t plus 1. Distribute, so we get 517t, 290t plus 290. We have to solve for t. So we subtract 290t from both sides. We have to get them all to one side. So it's 227t equals 290. Divide both sides by 227. So we have 290 divided by 227. 1.2775. Since we're dealing with times, we have minutes and seconds. Let's round it up to the second decimal place. So we look at the third number. Since that's greater than 5, we round up that number. But 0.28 is not 28 minutes. Because this is out of 100. Time is only out of 60. So what is 0.28 times 60? 16.8, approximately 17 minutes. So at 1 hour and 17 minutes later, that's when the planes were the same distance apart. Now, we have other ones to do. We'll do this tomorrow.